Hello, I am Mrs. Arnold, and today we are learning about plate boundaries. The main idea of this video is that volcanoes, mountains, and deep sea trenches form at the boundaries between the plates. Essential questions are: how does the movement of Earth's tectonic plates result in many geologic features? What are the three types of plate boundaries and the features associated with each? What are the processes associated with subduction zone? We are going to start this video by talking about the theory of plate tectonics. So it is useful then to define what a tectonic plate is. So a tectonic plate is going to be, well, tectonic plates are huge pieces of crust and rigid upper mantle that fit together at their edges to cover Earth's surface. So this is a map of the world with the major tectonic plates listed on it. And you can see that some of these plates, we have convergent boundaries. We know that because we have the two arrows coming together. And then at others of these plates, we have divergent boundaries. And we're going to define what makes a convergent boundary and what makes a divergent boundary. So plate tectonics is the theory that describes how tectonic plates move and shape Earth's surface. These plates, as you can see from the picture, plates are going to move in different directions, and they move at different rates relative to one another. And they interact with one another at their boundaries. So there are three different plate boundaries we are going to talk about. The first is divergent plate boundary. This is where two plates are moving apart. Then we have a convergent plate boundary. This is where two plates are moving together. And the last plate boundary we'll discuss is the transform boundary. This is where two plates are sliding past one another. And of course, when I talk about plates, I'm referring to the tectonic plates. So divergent, two tectonic plates moving apart, convergent, two tectonic plates moving together, and transform, two tectonic plates sliding past one another. Plate boundaries, most of them are going to be found along the seafloor in rift valleys. This, if you recall from last video, is where seafloor spreading happens. And also, if you recall, this is where we see ocean ridges as a feature that forms. So remember, ocean ridges are underwater mountain ranges. So that is going to form at divergent plate boundaries that occur underwater. The formation of new ocean crust at most of these boundaries is going to account for high heat flow volcanism, and earthquakes. A rift valley is what you get when you have a divergent plate boundary on a continent. The definition of a rift valley is a long, narrow depression created when continental crust begins to separate. You can see that forming here in this picture as these two tectonic plates move apart at a divergent boundary. Example that we are going to discuss is the East African Rift Valley. So this is a picture of the East African Rift Valley. So you can see the formation of the valley here. So what is happening here is that the African plate is splitting into two tectonic plates. It's splitting into the Somalian plate and the Nubian plate, and they are moving apart. Whoops. At a rate, of 6 to 7 millimeters per year. So that's how fast they're moving apart. So in about 10 million years, the Somali plate will break off and a new ocean basin will form. At convergent plate boundaries, this is when two plates collide. The denser plate is going to go below the other less dense plate. This is called subduction. It is very important that you understand this terminology. Remember that is referring to a denser plate going underneath another plate. So there are three types of convergent boundaries. We have ocean crust coming together with another ocean crust. So that would be oceanic. Then we have oceanic continental. And then we have continental. And of course, we are going to see different features occur at each of these. At an oceanic convergent plate boundary, there's a subduction zone form when one oceanic plate which is denser as a result of cooling, descends below another. This is going to create an ocean trench. And remember from the last video, this is where oceanic crust is going to be destroyed. This also makes volcanic islands that are going to form parallel to the ridge. Sorry, not ridge, to the trench. This is because the mantle is melting and magma is rising to the surface. An example here are the Aleutian islands, and if I remember geography, I believe they are off the coast of Alaska. So we have here two plates coming together, convergent boundary. This one's denser, so it's subducting, and then it is going to be destroyed and melt, and that magma is going to rise and create this volcanic island arc. Next, we have oceanic continental convergent plate boundaries. And here it is important to remember that oceanic crust is always denser than continental crust. So that means that it's always going to be subducted. So here, denser oceanic plate is subducted. This is also going to make a trench in a volcanic arc, like at the last boundary. So the difference here, though, is that it results in a mountain range with lots of volcanoes. Our example is the Andes Mountains. So what we have here is our oceanic crust that's subducting underneath the continental crust that is going to be burnt up, and the hot magma rises through the mantle, and that creates a volcanic mountain range that is on the continental crust. Our final convergent boundary is when two continental plates come together. So two continental plates are colliding. When this happens, the edges of the continental crust collide, become crumpled, folded, and uplifted. This forms a vast mountain range. In our example, we're going to talk about the Himalayas. So at where the Himalayas are being formed because it's a collision of the Indian tectonic plate in the Eurasian plate. And they have a growth rate of 1 centimeter a year. And so over a course of 1,000,000 years, that would be 10 kilometers in 1,000,000 years. So 1 centimeter doesn't seem like a lot in a year, but when you look at it in over time, it is a whole lot. So what happens here is that we have one continental crust that's kind of subducting because it's attached to ancient oceanic crust, so it's a little bit denser. And these crusts are just colliding and folding and making these huge mountains. Our last boundary is the transform boundaries. These are going to be offset by sections of ocean ridges, and sometimes these are going to form on continents. So that example would be the San Andreas Fault. So with the San Andreas Fault, it's pretty interesting because we have Los Angeles, which is located on the Pacific plate, which is on the west side of the fault. And then we have San Francisco on the North American plate, which is on the east side of the fault. LA is moving up and San Francisco is moving down. And in about 16 million years, Los Angeles will actually be north of San Francisco. But what does that that does mean that there will be a time where LA and San Francisco are right by one another. These are going to be characterized by lone faults and shallow earthquakes. So today we learned about the different plate boundaries and the geologic features that we see at each. Have a wonderful day.